So we're in chapter 12 looking at the tidyr package, and there are a couple of functions in here, particularly the pivot longer and the pivot wider that we're going to look at today. And we're also going to look at the separate command as well. So be sure to load tidyverse. tinyr, tiny data is part of the tidyverse, and we're going to draw some graphs, so be sure to load in the ggplot library. So this week we're going to be continuing our section on wrangling, and we're going to tidy up a data set, one that we get from the Baseball Almanac. And it has all kinds of statistics there, and we're going to look at the 2021 Detroit Tigers roster. And I'm going to ask you to bring in a file. This file, Tigers 2021 CSV, is at the e-learning site. You can download it there, but it's very, very similar to what you'll see right at the Baseball Almanac site. And when you view this CSV file, this comma separated value file, this is what you see. In this very first row up here, it looks like there's some kind of a title here, and then these are pretty much blank. So the column headings here don't really have a name. It looks like everything in row 1, these are the players' names, followed by their uniform number, their position, their height, their weight, whether they throw left, right, or both, whether they bat left, right, or both, and their date of birth. So one of the things we're going to want to do is to get rid of this top row so that we have only the data, and that'll be part of our tidying. So it seems reasonable that the names of the players should be one of the columns, and we're going to tidy up this whole data set. And what that means is that we're going to have all of our columns are going to have a column heading followed by all the values of that variable, and then all of our rows will be observations. In this case, it'll be the players. So it seems reasonable to set up the data file that way. And we can do all kinds of wonderful things with ggplot and other packages if we do have a data frame in that form, that tidyr format. This clue here says that one instance of pivot longer followed by an instance of pivot wider should be sufficient to bring in your CSV file to a 49 by 8, with the 8 variables being the player, the uniform number, the position, the height, the weight, throws left or right, bats right or left, and the date of birth. We're going to separate the height variable. Here you can see it. It's 6-02. This means 6 foot 2 inches, and similarly here we're going to break this apart and then reform it again by mutating a new variable called height, replacing the old height, but the new height will be just in inches. Okay, let's take a look at how this would play out. So remember to load those libraries and then check your directory. Here's my current directory where I'd save that Tigers 2021 file. I'm going to look at the dimensions of the Tigers file as we go through. And if you want, you can view the Tigers file in a frame up here. All right, now to get rid of that one extra row at the top, here's how you can do it. You can just say skip equals 1, and that'll get rid of that one extra row that we had up there at the very top. Notice when we do that, the dimensions are now 7 by 50. We lost that one row. If you look at the tibble, you can see now the top row is the names of the players. What used to be that blank row with the title is no longer there. But we have a weird name here for the players. It's called details for some reason. And you can also view that in a table as well. All right, so we're going to use the pivot longer and pivot wider commands to tidy this up and get it into a nice frame that everything looks in the format we like to have it. And remember, there are 3 things. You have all the variables in their own columns. You have the observations in the rows, and every cell has to have a value. So when we come down here, what we're going to do is we're going to take this whole thing right here, this data frame down here, and we're going to ignore the details column because that contains all of the different variable names. We're going to ignore that for now. That's what this take it out means. And then the first row, which were the column titles, they're actually names of players. So we're going to take all those column and we're going to name it to player, which is what they should be. And then all of the values of these individual columns, all of this stuff down here gets stored in the player column stats. So let's see what that looks like. We run that assignment statement, check the dimensions, and check this out. The new dimensions of our matrix are now 343 rows by 3 columns. What could possibly have happened? Well, this pivot longer command really does make your table longer, in this case 343. And you can see what it did here. We have 49 players on the Detroit 2021 roster. There are 7 variables each. The first one is that the uniform is equal to 70 for Tyler Alexandra. When you get down to, say, row 50, you're going to see another Tyler Alexander, but it might say height equals 6-02. The players' names are going to repeat every 49 with a new variable. So you made it longer. And that's what you're seeing here. Now, the next thing we're going to do is to make this table wider. So we're going to take, remember, this is the details column that has all of the variable names. We're going to take the names from that details column, and we're going to recall all of the player stats that we stored up here. Look how nice this is. We run the assignment statement. The dimensions now are, remember what they were? 343 by 3, and now they are 49 by 8. 49 players, 8 different variables. Let's take a look, and there they are. Notice the player column used to be details. It's been renamed as players. We have every value in this column is a player name. Every value in the uniform column is a player's uniform. Every position is the player's position, height, weight, and so on. Okay, the next thing we're going to do to tidy up this data is we're going to change the heights, and we're going to separate it into these two, feet and inches, and the separator is going to be the dash. So because we have them ordered this way, the first before the dash is going to be the feet, and after the dash is going to be the inches. Now, when you do this and you separate, the column height will no longer exist because we're breaking it up into 2 different columns. So we're going to go from 8 columns to 9 columns here. We lose height, but we gain feet and inches. There it is, 49 by 9. And then you'll notice we have feet and inches here, and we don't have height any longer. Column types in this example, many of them are wrong. We want to change feet and inches and weight to doubles, and we want to change the date field over here to a date. And we can do that by using a combination of mutate across. Weight is numeric, feet is numeric, inches is numeric, and then the date of birth as a date. All right, not much is going to happen here, but when you run this, the dimensions are the same as you can see, but now in the tibble, you'll see that these 3 columns have been reclassified as real numbers, and this one over here has been reclassified as a date field. We're going to rename the height field, and we're going to use feet and inches because they're now numbers. We're going to define the height in inches. So we multiply the feet by 12 and then add the inches. And you can see when we do that, we add another column because we've mutated height. So we have both feet and inches and height now. And there it is. You'll see height was added on to the end. We were asked to display only these 8 fields. So we're going to run the select command, and then when we look at the dimensions there, you can see we're now back down to 8. And here is our final tidy data set. So putting it all together, if you put all those 6 pieces together, you bring in the data, and then you run this one piece of code here. Here is the tidy data set. There's the original, remember that one? Back to the tidy, and then you can view it if you like. And the last step would be to save it. So take your Tigers 2021 tidy frame and save it to the name that you were asked to save it into. Now that we have this tidy data, we're going to throw in a couple of visualizations. So using the Tigers 2021 tidy data, we're going to draw a scatter plot. The x-axis is going to be height, the y-axis is going to be weight, and we're going to color by the 4 positions: pitchers, catchers, infielders, and outfielders. So you should see 4 different colors on this scatter plot. Let me bring this over. So here's a scatter plot. You can tell that pitchers, they tend to be the bigger players on the team. Mostly they're big, they're tall. And when they have tall, they have long arms. And so if they have long arms, those long levers on them can throw the ball faster. And so you typically see a lot of pitchers who are big. So if you look at all the purples are all 75 inches and taller. There's a couple of shorter ones over here, but most of those purple dots are over here. Whereas the outfielders, they tend to be over here in the shorter. There's not as many of them, first of all, as you can see. And the reason there's not as many of them is because they're so expensive. They usually tend to be the better batters on the team. And because of that, they can command big salaries. So there's not as many of them on the team. The next visualization, again, we're going to look at the Tigers 2021 tidy data. This time we're going to do a box plot. Horizontal axis is going to be position. So we're going to have the 4 positions. That means 4 box plots, and we're going to compare the weights. And we said that maybe pitchers are heavier. Let's see if that's the case. When we look at the box plot, you can see that the outfielders tend to be on the lower side of the weight. The pitchers, they have a large variation in their weights. This person right here weighs more than 275, but it's because probably they're very, very tall. Infielders, most of them are in here, but they vary. You've got some infielders that are very, very small, and you got some infielders that are very, very big. You might guess who this person is here. And that particular infielder right there is Miguel Cabrera. And in the third visualization, we actually do a little bit of a redefining of a variable. We're not filtering anything out, but we're creating this new data frame from our old data frame, and we're going to mutate a new variable. And the new variable is similar to the position, pitcher, catcher, infielder, outfielder, but we're going to break it down that you're either a pitcher or you're a non-pitcher. And so the way that this if-then-else statement works is that if the position of the player is a pitcher, then we're going to declare the position to be pitcher. If it's not pitcher, then we're going to declare, like catcher, infielder, outfielder, we're going to declare the position of the new variable to be non-pitcher. And that's what this one does. It mutates to Tigers tidy data 2. And so when we want to come down here and graph Tigers tidy data 2, you can see we're going to look at whether they bat left-handed, right-handed, or both on the x-axis. And the color we're going to fill this bar graph with is the position, pitcher, or catcher. And we're going to do a multiple bar graph. So that's what the position equals Dodge. By the way, this position is not the same as the position of the player. So that can be confusing. So let's run this one. First, let's set the new calculated variable, and then we do the multiple box plot. And there you can see when you set it up like this, it's a small scale over here, so it's fairly easy to count the number of pitchers and non-pitchers that bat in each of the different ways. A lot of times pitchers don't do a lot of batting. You can see it looks like there's about 1 pitcher that bats both ways, but there are 5 other Detroit Tigers that bat both ways. They generally bat left-handed against right-handed pitchers, and they bat right-handed against left-handed pitchers. And you can see overwhelmingly you have more righties on the team, on any team, because there are more right-handed people in the general population. However, it's only about 10% of the general population are left-handers. And you can see it's much more significant than that. If we look at all the lefties, all right, that's these folks here, we have about 4 here, and we have about 6 here, so that's 10. That's 10 of the, say, 49 players, and that's 20% of the players are left-handed or bat left-handed, whereas in the general population it's closer to 10%. So have fun this week generating your own investigations and your own graphs of the Detroit Tigers 2022 roster.